let's take a look at the integral of e to the 2x times sine of 3x dx. This is another integration by parts integral because it's an exponential function times a trigonometric function. Usually products of exponential and or trigonometric functions can be done by integration by parts. In any case, here we want to separate these two functions to u and dv, and well, either way, either way, whether or not you let e to the 2x or sine of 3x be u or dv, it's going to end up being pretty much the same thing, since taking the derivative or the integral of either a trig or an exponential function doesn't really do anything. So let me just call this u and call this dv, kind of in alphabetical order from left to right. If u is e to the 2x, then du is 2e to the 2x dx. And if dv is sine 3x dx, then v is going to be minus cosine of 3x over 3. Right? Anyway, let's use the integration by parts formula to get integral of e to the 3x, e to the 2x sine 3x dx is equal to uv, that's e to the 2x times minus cosine 3x over 3 minus the integral of v du, that's minus cosine 3x over 3 times 2e to the 2x dx. Okay, let's simplify this a little bit. This is minus e 1/3 e to the 2x cosine 3x, and then minus minus is plus the integral, or 2/3 the integral of e to the 2x cosine 3x dx. And now if you look at this second integral, it's pretty clear that we need to do it by parts again. So let me put a little box around it and kind of bring it down here. So integral of e to the 2x cosine 3x dx. Okay, so now let's do parts again. Before we did u as e to the 2x, it's actually pretty important to make the old du the same u again when you do integration by parts a second time. Otherwise, what may happen is that, you would cancel out what you did in the first integration by parts. So you don't really want to do that. We have already done a lot of work. Let's not undo that. So let's call this u, and let's call this dv. So if u is e to the 2x, once again, du is 2e to the 2x. dv is cosine 3x dx. And so v is going to be sine 3x over 3, no dx. Okay, so this integral e to the 2x cosine 3x dx is going to be uv, that's e to the 2x times sine of 3x over 3 minus the integral of v du, that's sine of 3x over 3 times 2e to the 2x dx. And that this sort of third integral, I guess, should look familiar because it's exactly 2/3 of the integral that we started with. So first of all, before we actually go to actually solving this problem, I mean, it's pretty clear that we kind of got back to where we started. So if we did integration by parts again, we'll just keep kind of going in a loop. So it's actually easier if we're a little clever about this and kind of just write the whole thing out. But I also don't want to write the whole thing out multiple times, so I'm just going to call this integral I. So the integral of e to the 2x sine 3x dx is I. That means that, let's see, I integral of e to the 2x sine 3x is equal to, let's go back up here, minus 1/3 e to the 2x cosine 3x e to the 2x cosine 3x, and then I had plus 2/3 times the purple box, and the purple box is, let me purple box this one as well. And so replacing the purple box up here with the contents of this purple box, we get e to the 2x times sine 3x over 3 minus, this is 2/3 of I. So it's nice not having to write that entire integral again. Let's simplify this a little bit. We have the equation I equals minus 1/3 e to the 2x cosine 3x. Multiplying the 2/3 through, we get plus 2/9 e to the 2x sine 3x minus 4/9 I. Bringing all the i's to the left, 1 plus 4 over 9 would be 13 over 9. 13 over 9i is minus 1/3 e to the 2x cosine 3x plus 2 over 9 e to the 2x sine 3x. So I would be equal to 9 over 13 times minus 1/3 e to the 2x cosine 3x plus 2/9 e to the 2x sine 3x. And we can simplify this a little bit more by pulling out a 1/3 e to the 2x. So this would be 9 over 39 e to the 2x times, and let's put the sign in front because it's got a positive, 2 over 3 sine 3x minus cosine 3x. Let's remember to put a plus c here. This would be the antiderivative of e to the 2x sine 3x dx, and we got this essentially by doing integration by parts a couple times until we got back to our original integral, which we called I, and writing down the equation involving that original integral I, and kind of just solving for I. It's not very pretty, but it is doable. And since it's a first degree, it's a linear equation, solving for I isn't actually that bad.